All right, number four. Number four is going to go back to this equation here, that delta G is equal to delta H minus T delta S. That's there. Now, it wants to know whether or not the reaction will be spontaneous. Well, if it's going to be spontaneous, then that means the delta G has to be negative. So this goes to what we talked about in the lecture. What kind of conditions for this guy and this guy are going to lead to this guy being negative? Well, this guy is going to be negative, obviously, if the delta H is negative. That helps the process. And again, if the delta H is negative, then it is considered to be enthalpy driven, right? And this guy will also end up being negative if this guy is positive, right? Because if that guy is positive, you will then be subtracting a positive number, and if you subtract a positive number here, then that's going to make him more negative. So if that's the case, if delta S is positive, then it's considered to be entropy driven. So that is your first possible circumstance here. Circumstance number one is that if you have a negative delta H and a positive delta S, then this is always going to be negative, and therefore this is going to be spontaneous at all temperatures. Okay? Well, what if it were the opposite of that? Well, if it were the opposite of that, if you had a positive delta H and you had a negative delta S, then this is not enthalpy driven. And this is not entropy driven. So you have a positive number of which you're going to be subtracting a negative number, and if you subtract a negative number, that makes it even more positive, and so consequently this is always going to be a positive number over here, and if it's positive, that means that this guy is never going to be spontaneous no matter what you do. So this guy is never spontaneous at any temperature. Your third possibility is if they compete with each other. What if I have a positive and a positive? Well, if it's positive delta H, then it is not driven by the enthalpy, but it is driven by the entropy. So consequently, what's that going to mean? Well, if I want the entropy driver to be larger than the not enthalpy driver over here, if I want this to be small, and I want this over here to be a big value, then how can I adjust that? I can adjust that by using my third factor here, which is the temperature, and making temperature big. Because then what I have is I have a small number here that I'll be subtracting a big number here because the temperature is big. And so when the temperature is big, this will end up with this guy over here being negative and therefore spontaneous. So this guy is only spontaneous when the temperatures are high. And again, we talked about this in the lecture. And then our final one here, number 4, is going to be the opposite. If this is negative and negative, then what you want is you want this to be big because you want this to be the enthalpy driver. So this is enthalpy driven. And this is not entropy driven. So you want this to be small. How do you make that small? You make that small by making the temperature small. Because if you make the temperature small, then what you have is you have a big negative number here, and then you're going to be subtracting a small negative number, because again, this is as small as you can make it. And so if you have a big negative number and you're subtracting a small negative number, that means that you are essentially adding a small number. And so this will end up being negative only when the temperature is small. So this is going to be spontaneous at low temperatures. So these are your 4 possible circumstances. If it is negative here and positive here, it's always spontaneous. If it's positive here and negative here, it's never spontaneous. If they are positive and positive, it's only going to be spontaneous at high temperatures. If it's negative and negative, it's only going to be spontaneous at low temperatures. So this is negative and negative, which means that this is an enthalpy-driven, but not an entropy-driven one, so it'll be spontaneous at low temperatures.